This lesson is parallel lines and proportionality. The objective says I'll be able to identify proportional figures and or proportional corresponding parts within triangles or parallel lines cut by transversals. So some review: parallel lines are two coplanar lines that never intersect, and a transversal is a line that intersects two or more lines in a plane at different points. So if these lines are parallel, if this is a transversal, it cuts off pairs of angles. And we've looked at these before, and we have many angles that are congruent. I'm just going to put the big little pattern on here. Okay, all of those angles have the same measure. All of these angles have the same measure, and every combination of a big and a little, or B plus L, is 180, or supplementary. Okay, so now let's look at the triangle proportionality theorem. It says if a line is parallel to one side of a triangle and it intersects the other two sides in two distinct points, then it separates these sides into segments of proportional length. So in other words, when we have a triangle and you have these parallel lines here, there are many proportional relationships that it creates. So here are four of them. You can take the measurement of CB and put it over the whole side CA, and that's a ratio, and it would be equal to the measurement of the other side CD over the whole side CE. Okay, let me clear that. And then let's look at this one here, BA. So BA is this little part right here, and if we put that over the entire one, we can put DE over that entire side, CE. Okay, I'll clear that. Again, this is CE and CE. And then we have CB, this part over the bottom part, and that would be equal to CD over DE. One thing that we haven't looked at yet is we actually can go side to side as well. So if you look at BA over DE, that would be equal to CA over CE. Okay, so there are a lot of different proportional relationships that are created. So when people solve for missing measurements, sometimes they'll set them up differently. I like to just kind of be consistent so that I learn one way. One way I try and tell people to go from one triangle to the other. There's a reason for that, but there's a lot of different ways. But if I put 5 plus x in the top of my ratio here, and then if I go to and put 3 in the bottom, then I'm going to put 8 plus x over 4. Let's cross multiply. I'm going to get 20 plus 4x is equal to 24 plus 3x. If I subtract 3x from both sides, I get x. If I subtract 20 from both sides, I get x is equal to 4. Okay, let's look at maybe setting it up a different way. What if we put 8 plus x over 5 plus x and set that equal to 4 over 3. Okay, what you're going to see is when we cross multiply here, we're multiplying 3 times 8 plus x. When we cross multiply over here, we're doing the same thing. Cross multiply here, it's 4 times 5 plus x. When you do it here, it's the same way. So in all these relationships, once you cross multiply, you're going to end up with the same problem. So there's a lot of different ways you can set it up. The answer is x equals 4. Okay. So in the quick check, you should pause this and do it yourself. Okay, so I'm going to put, and I'm going to use x instead of a because my a's look like 9s. X plus 1, x minus 1, I'm sorry, over 1 is equal to 2x plus 8 over 7. And then when I cross multiply, I get 7x minus 7 equals 2x plus 8. So subtract 2x and you get 5x is equal to, if you add 7, 15, x equals, or a equals 3. Okay, now the converse of the triangle proportionality theorem says if a line intersects two sides of a triangle and separates the sides into corresponding segments of proportional lengths, then the line is parallel to the third side. So in other words, they give us a picture here and they give us some measurements, and what we're going to do is we're going to write those measurements, e.g., so this whole thing is 15, EH is 5, LG is 12, and FL is 6. So I'm going to go ahead and put HG, 15 minus 5 is 10. And so we look and see if we have proportional segments. And if we do, then we can say that these lines are parallel. So if I put 5 over 6 and see if that's equal to 10 over 12. And we can see when we cross multiply, we get 60 is equal to 60. So yes, they're proportional. So HL is parallel to EF. Okay, so you should pause and set this one up yourself. AC is 30. AD is 10. AE is 22. And EB is x plus 4. So 30 minus 10 is 20. So I'm going to put 10 over 22 is equal to 20 over x plus 4. When I cross multiply, I get 10x plus 40 is equal to 440. Subtract 40, divide by 10, and x is equal to 40. So it says find x so that the lines are parallel. So we solve for x and it's 40, and if x was 40, that means that this would be parallel to this. Okay, mid-segment. We've talked about mid-segments before, so this is just a review. A segment whose endpoints are the midpoints of two sides of a triangle. So midpoints goes there. So the mid-segment theorem tells us a segment whose endpoints are the midpoints of two sides of a triangle is parallel to the third side of the triangle, and the length is half that of the third side. So in these examples, use the mid-segment theorem to set up and solve an equation to determine the values of x and y. So if this is a mid-segment, and I guess they're telling us that these are mid-segments, they don't explicitly write there, that means that those two are midpoints, and so x would be half of 26 or 13. And in the quick check, again, if this is a mid-segment, the mid-segment is half the other side, so if this is 5, x would be 10. So you're either dividing by 2 or multiplying by 2. In example 4, then, we're going to solve for missing measurements here. Now, we see that we have congruency marks. So that is congruent to that. So you're just going to set them equal. 4y plus 6 equals 2y plus 18. Subtract 2y and you get 2y is equal to, subtract 6, 12, so y is 6. And now to find x, because we know that this is congruent to this, we know that's a midpoint. And over here again they show congruency marks, so that's showing that these are midpoints. So if those are midpoints, this is a midsegment. So that means if I multiply 2 times my midsegment, I get the third side. So 8x minus 10 is x plus 11. If I subtract x from both sides, I get 7x. If I add 10, I get 21. So divide by 7, and x is 3. Okay. Sorry it's so messy to write on here with these pens. If 3 or more parallel lines intersect 2 transversals, then they cut off the transversals proportionately. So here we have more than the 2 parallel, we have 3 parallel lines. And so the segments are cut off proportionally. So PQ over QR is congruent to DE over EF. Or, let's use a different color, PQ over DE is congruent to QR over EF. Okay, again, more than one way to set it up. And now we're going to solve for some missing measurements here. So we have 3 lines that are parallel, so the segments are cut off proportionately. So over here, 6 minus 2 is 4. So I'm going to put, that's going to be my x. 2 over x equals 4 over 8. So 16 equals 4x. So x is equal to 4. Over here. Okay, I'm going to put x here, but they're asking for the entire length, okay? They're trying to ask for the whole thing. So just, we solve for x, so 3 over 6 is equal to 4 over x. Get 3x is equal to 24. X is equal to 8. But then the entire segment would be 8 plus 6 would be 14. Okay. So be careful and make sure that you see exactly what they're asking for. And just checking. Okay, we still have a little bit more to go. I'm going to have to pause the video and finish it in a second one.